In question number 4, we have that in a circuit there is, question number 4, resistors that only have one ohmic value are called fixed. Okay. So let's keep moving. So we already covered in class the difference between fixed and variable. Mostly we were using fixed resistors. But in other levels, like in level 2, you are going to be able to use variable resistors for different applications, to change voltage, to change frequency, to make them behave as a dimmer. So that's something that you are going to be able to do in the next level going forward. Okay, so the diode is often called a PN junction, and that is true as well. Because a diode is made of two semiconductor material, a p-type and an n-type semiconductor material. Okay, question number 6, the conventional current flow theory assumes that current flows from positive to negative. So we gotta be careful with this question because we gotta remember that it says here conventional. So we have two different theories, the conventional flow theory and the electron flow theory. The electron flow theory dictates that current flows from negative to positive because the electrons are negative and they are flowing towards the holes, which are positive. While in the conventional flow theory, we have that current flows from positive to negative because what is it flowing? We say that holes are flowing. Okay, they are the one moving in the opposite direction of the electrons. So, and by all means, in the conventional flow theory, everything flows from positive to negative. Okay, so let's keep moving. Like in question number 7, we have that diodes can be connected to form a three-phase. How many diodes has to be connected to form a three-phase bridge rectifier that will change three-phase AC voltage into DC? In this instance, it's going to be 6 diodes. Okay, so far, like we were able to see, like the amount of diodes that we need for single phase. However, like when it comes to three phase, because we have line 1, 2, and 3, we are going to need 3 basic diodes that allow the current to flow in one direction and 3 more diodes to behave as the return path for that current. Okay, so in question number 8, we have that if not current flow through the base of a transistor, so I want to remind you that transistors has 3 different pins. So, okay, so I'm gonna try to recreate here a transistor. And the 3 pins that we have for a transistor are, okay, so let me just try to recreate a transistor here for you guys. So let's say that here we have a PNP transistor, and NPN, sorry, not PNP. And then we have our 3 pins. Remember the name of these pins? Can you please type it? Because I can hear you. I'm sorry. Really apologize for that. I promise that for next class, I will be able to hear you loud and clear. Okay, so remember what is the name of this? Base, emitter, and collector. So right here, we have our base. Right here, we have our what? Our collector. And right here, we have the emitter, which in the case of an NPN is going to be connected to ground. Now, the question says then that if not current flow through the base, if we don't have any current through the base, the transistor is acting like a closed switch. Absolutely false. Okay, it's going to be behaving as an open switch. So for the transistor to behave as a closed switch, it needs to have a base emitter current. So let's keep moving. Any questions about that? Oh, we are good. No questions at all? Okay, so let's keep moving then to question number 9. In question number 9, we have that a resistor made from a compound of carbon graphite that kind of is giving away carbon graphite and resin bonding material. It is called what? Well, it cannot be metal, film, or metal glaze, or wire wound. So the carbon is giving away the question. Okay, so it's a composition carbon resistor. As we keep going into question number 10, and then like blank of a resistor indicates the plus and minus limits of a resistor's ohmic value. So, and we know that that is the tolerance. Okay, so it's telling me that we only have like a few seconds left because these tests have like a 10 limit time, but that's okay, we'll finish it. I'm spending a lot of time talking and a lot of time trying to explain. I want your feedback, like, is this helpful or I'm just wasting your time in this case? Is this helping you at all? Okay, perfect. Thank you, Robert. It's good to know that it's helpful. Okay, perfect. Thank you guys for the feedback. So let's get moving. So question number 11, germanium, and the other material for semiconductor is silicon, germanium and silicon, and you were able to use in project number 4 both diodes. I mean, provided that you were able to use to do the project 4 in the shop, but I think you did it online. So you were able only to see like the consequence of using either germanium to silicon. Okay, so the next question is, transistors are made by connecting 3 pieces of semiconductor material. And that is absolutely true. Because in the case of transistor, they can either be NPN, which means negative, positive, negatives, or they can be PNP, which means positive, negative, positive. Okay, so in question number 13, when a semiconductor material is mixed with an impurity that has, then we have a blank space, such amount of electrons, such as arsenic or antimony, the lattice structure have an excess of electrons. So in order for us to have an excess of electron, we got to keep in mind that silicon, okay, like in the case of silicon is going to have the lattice structure of silicon only have 4 electrons in the valence shell. Okay, now when we add an impurity, okay, so I'm just going to use something else to signify that we have an impurity here, and then that impurity have 5 valence electrons. So in that instance, the 4 electrons is going to share another valence electrons with all the neighbor atoms. However, because we have 5, we are going to have an electron that is going to be free to travel. And in that instance, because we have more negative charges than positive charges in that material, that is considered to be an M-type material. Okay, so that becomes an M-type material. So in that case, it's 5. So let's keep moving. In question number 14, a resistor is made by applying a film of carbon. Okay, so again, the question is giving everything away. A film of carbon to a ceramic rod. Of course, that has to be like carbon film. Okay, it wouldn't be to be wire wound because it's not talking about wires. It's talking about carbon. And it cannot be metal because the question is talking about carbon, and it cannot be metal glaze because again, for the very same reason. Okay, so let's keep going, guys. So question number 15, an ohm meter can be used to test a transistor, which will appear to the ohm meter to be 2 joint diodes. So just to remind you how that works, I want to remind you that when we have a diode And I'm just going to try to use, well, this. I was going to try to use that arrow, but that's not going to work. So I'm just going to use this. So when we have a diode like this,
Are you watching this stuff?
We know that a diode have two components, or it have like two different materials. One of them is going to be the positive, which is that side, which is the P positive, or also is called the anode. And then the other side is going to be the negative, which is called the cathode. Okay, so to a meter, it seems like if we have two diodes connected back to back. So if I connect a second diode and I decide to connect or to join in common union the P material of my diode, then we would be able to have an NPN, transistor. So now when we take a meter, and let's simulate that we have a meter here. Okay, so this is going to be my meter. And I connect my positive and negative terminals, or my positive and negative, to this diode, or excuse me, to this transistor. So if I'm going to be connecting my red, and red symbolizes the positive, if I connect my red right here on this joint, and I connect the black right here into the N, because that portion of the semiconductor material that you have in the transistor is going to be forward biased, the meter is going to indicate continuity. Okay, it's not going to indicate zero. It's going to indicate that we have a closed switch. So it's going to give you like something which is going to be close to 0 ohms. Okay, just indicating that we have continuity that is forward biased. On the flip side, if we wanted to measure the other side, then what we do is that we are going to be connecting then the black lead to the other side of the transistor. And again, it's going to be reading continuity, and you will know that by all means that that because it has continuity, that side or that semiconductor junction, it is also good. And on the flip side, when you reverse the connection and you connect the negative to the positive and the positive to the negative, then now the ohm meter should indicate OL. Okay, why is it that it should indicate OL? It means over the limit. It's over the limit of the capacity that the ohm meter has to measure resistance. So that means that your semiconductor, your PN junction, in this case, that PN junction portion of your transistor, it is reverse biased. And that means that OL means that it's good because it's behaving as an open switch. Okay, so let's keep moving. So as we continue here, a potentiometer, it is a variable resistor. That is absolutely true. Any questions about, everybody knows, I guess, what is a pot, right? A potentiometer. And I could ask you, what's the difference between a potentiometer and a rheostat? And remember, what's the difference between the two? Any comments? Okay, so I just got to remind you that a potentiometer has 3 leads, 3 terminals, and it is used for low current applications, while rheostats, they could have 3 terminals, but usually they have 2, are basically used for high current applications. Okay, so let's keep moving. So diodes cannot be connected. Diodes cannot be connected to produce full wave rectification. That is absolutely false. Because what we know that when we have a center tap transformer, okay, so let me remind you that if we have a center tap transformer like this, where we have a common, we have line 1, and we have a common that we are going to call the neutral, and we have a second side that is called line 2. If we connect one diode to line 1 in forward biased, and we connect a second diode to line 2, and then we made a neutral the common connection, now we are going to be able to have full wave rectification. So because line 1 and line 2 are 180 degrees out of step with each other. What does that mean? That the sine wave on line 1 looks like this. At the same moment, the sine wave on line 2, okay, and I'm going to use black just to make sure that we have a different color for this, will look like this. You can see that when line 1 is positive, line 2 is negative, and that's why we can have a flow of current, because current will flow from, in conventional terms, positive to negative. So that's why that line 1 is going to put its share of a half wave like this. But when line 1 is silent or is 0, then at that time, line 2 is going to kick in because it's going to become positive when line 1 is negative, and then it's going to contribute with its share. So on the load itself, everything is going to be seen as what is called full wave rectification like this. Okay, so you will never have a lag period. You will never have a time when a signal is absent from the circuit. So let's get moving. As we continue here, a resistor is made by applying a film of metal to a ceramic rod. Well, the wear is giving everything away. Film of metal. I don't even have to think about the answer. That is metal film. Okay. So the next one, ground, is generally considered to be how many volts? Okay. So ground is how many volts in an electronic circuit. Ground should always be 0 potential. The reason why everything in the electrical industry is grounded or bonded to ground is because what is the potential difference that we have between livestock and humans to ground? How much is our potential to ground? 0. There's no any potential. That's why we can walk all day long with barefoot, and other than just getting dirty from work, walking, with barefoot, nothing's going to happen to us, hopefully. Okay, but I'm just kidding, in the sense of hopefully. So because of that, like in all circuits, ground is always the 0 potential line, okay? So it's also called the neutral plane and the 0 potential plane. Okay, so last question then. A resistor is made by combining metal with glass and then applying it to a ceramic base. That would sound more like metal glazed, okay? Because we are combining metal and glass. Anyways, like, I am afraid now to submit the quiz. Do you think that we all gotta be able to get 100? I mean, like, I made the test. I should be able to get 100. but I'm afraid that I made one of the questions wrong. But okay, let's go ahead. Let's see if we get it right. Oh yeah, we got 100% right here. Okay, so, and that's what I'm going to be expecting that you are going to do whenever you do these quizzes, if you don't get 100%. So let me make sure that you can see me. So I was going to tell you guys that when you are doing these quizzes, if you don't get 100%, I honestly hope that because you have 7 attempts, that you are going to take the time and that you are going to answer all the questions that were not right on the first attempt. You will always have access to do the quizzes as many times as you need. If 7 times is not enough, you just let me know, and I'm going to be opening the quiz in such a way that you can write it as many times as you please. My most important goal or the most important thing for me is that you can remediate all your quizzes to 100%. I mean, when it comes to practice quizzes, okay? Any questions before I let you go for today's class? Type it because I won't be able to hear you. I'm sorry again for that. But if you have any questions, please type it and I'll make the other 3 quizzes available right away. So somebody's asking something. Okay, Andrew says all good. So everybody knows that we have our final. Okay, so, and also one thing which is important for the final, guys, I'm gonna be posting the recording, but I started recording this class when we were in the 4th question. So yes, I'm gonna be posting that video between today and tomorrow, okay? So I was going to tell you guys that the test is gonna be open from 6 in the morning until almost like midnight, until 11:30 at night. That's going to happen on February 8th. That way you are going to have the flexibility to do the test throughout the day. And honestly, because you are going to have so much flexibility, I am hoping that you are going to take the time to do this final exam slowly. So I wish that everybody gets 100%, with all honesty. That would mean that I am a good teacher. Just kidding. That would mean that you are good students. Anyways, guys, so this is good for today. I wish you a very nice week. And I'll see you next Monday to continue with these reviews. So Godspeed and God bless you. See you guys.